Before we start learning R, it might be a good idea to take a look at what R actually is. And it's often said that it's a programming environment, meaning that it's both a standalone executable software program and a programming language for management analysis and presentation of data. When you write an R command and execute it, it's not executed directly, but it's sort of translated into other languages, including C and the very old one, Fortran, before it returns the results that you wanted. But most of R is actually written in R. That might seem a bit odd or circular, but the fact is that the R program contains only a small number of core functions, R functions, that are encoded in C, Fortran, and so forth, while most of the R commands actually calls for other R commands, which in turn may call for yet another R command, which may be encoded in these other languages. So most of the commands are written in R. And we'll mainly use the base package, which is included when you install R on your computer. But if you need additional commands, you can easily download packages to extend the capabilities of your R installation. And you can also download script editors of different kinds and shells to make R look better and be more user-friendly in its interface. And a bit about the history of R. The history of R actually starts with S, another programming language that is very similar. One might say that R is actually a copy of S. And S was developed in 1976 by the Bell Laboratories. Bell Laboratories was initially a company within the AT&T telephone company, and its mission was to develop switchboards, basically, for AT&T. But apparently they had a lot of extra resources because they also managed to develop the transistor, the laser, the CCD sensor, radio astronomy was invented there, and they developed the Unix operating system, C and C++, and of course S. And it's also received, or researchers there have received, 8 Nobel Prizes in all. At this time, in the 70s, there were no real statistical software, but the statisticians had to be programmers and design the functions they wanted to use or code them themselves. And this had to be made over and over again, so there was a lot of unnecessary work. And within the Bell Laboratories, they thought it might be a good idea to develop the software with standardized statistical functions that could be reused by the company's statisticians and researchers. Later on, it was developed into S+, a commercial product that is still on the market, and it may seem a bit odd that there is one commercially available paid-for software and one that is for free with basically the same functionality, but apparently there are markets for both of these. And in 1991, Ross Ihaka and Robert Gentleman at the University of Auckland decided to develop a statistical environment by themselves based on S, and the result was R. And R here is a reference to the names of these researchers, Ross and Robert, but it's also because R is the letter adjacent to S in the alphabet. In 1995, R became integrated into the GNU project, and GNU is a project that supports development and distribution of free open source software, which R is. It's also an acronym, or a recursive acronym, for GNU's not Unix, which might seem a bit childish. That's the way it is. In 1997, Ross and Robert found that the management of R, the questions they had to answer and the suggested changes and updates. In 1997, Ross and Robert found that they had to put a lot of work into managing R with requests from users and questions and things. So the management was transferred to something called the R core group, which is really a large group of bearded men. And a lot of the members in the R core group comes from the S+ sphere and works there daytime and manages R in their spare time, indicating that there is no hard feelings between the two programs, so to say. Since then, R has gained an increasing use in a lot of large companies, for example, Google, Facebook, Twitter, Microsoft, Lloyd's, the insurance company, Bank of America, all uses R. And authorities such as the FDA and also a lot of universities worldwide use it, probably because it's free. It's not quite easy to determine the number of active R users because you don't have to register anywhere and you can download it as many times as you want and into as many computers as you want. But an estimate from 2014 was that there might be somewhere around 2 million active users worldwide. So why should you use R? I would say that depending on what the alternative is, one of the most important things is the traceability and the documentation, because if you perform an analysis in a program with a lot of drop-down menus and checkboxes, it might not be that easy to afterwards find out what you actually did and if there was something wrong to it. While in R you write code, and if you save this code, which you should do, then you have clear documentation of what has been done, exactly what you have done. It also saves a lot of time, especially when you have to repeat the analysis, because if you perform a large analysis with several steps and, for example, there is something wrong in the first step, you don't have to repeat everything, but you just make the changes necessary and correct the errors, and then you rerun the entire script and you get the new results in no time at all. It's very powerful. You can do almost anything. I usually say that if you can think of something that you would like to do within the realm of statistics or graphics, then it's probably doable in R. You might not be able to because you don't know how to, but R could do basically anything you can think of. You get access to new methods in an early phase, and that's because a lot of the development of new statistical methods is made in R by statisticians, and it could then take quite a while until they show up in the commercial softwares, because they will have steering committees that have to decide whether or not to integrate this into their program, and you have programmers that have to get the time to implement it into the software, but usually it turns up in R first. R also has excellent graphics features, and that's something you may tend to forget if you look at it as just a statistical software. But I, for example, use it, I would say, a lot more for producing graphics than for statistical analysis. And of course, R is free. You don't have to pay for it, and it's open source. That's an important feature. It's platform independent, which might be true for other softwares as well, but you can use it in the Windows environment, you can use it on an Apple computer, or you can use it on a Unix computer. And you can get a lot of help with R for free. You don't have to pay for support, but you can find a lot just by Googling. I would say most of your problems can be solved that way, and there are net forums where you can post your questions and get answers from the user community. So it's a very active community around R. And last but not least, it's a lot of fun. I have used quite a few statistical softwares, and I really must say that R is by far the most rewarding one to use because it's always fun, almost always. It can be frustrating from time to time, but it's a lot of fun, and actually I would say that the best part of my work is when I get to code R for an entire day. But of course there are cons as well. Not everything is great about R. One such thing is that it's rather difficult to learn because you don't have a real graphical interface. You have to code everything, you have to write script. So you have a high threshold. In a program where you can find the commands in drop-down menus and things, you might be able to, even if you don't know anything about the program, you might be able to perform a simple analysis, while in R you just have to prompt and you have to write something, and if you don't know what to write, you won't get any results at all. So you have to learn a bit before you can do anything in R. There are also quite a few syntax inconsequences in R. And that is because the new commands are written not by a small group of programmers which can adhere to specific rules, but it's written by the users, and a lot of them. So although there are recommendations as to how the syntax should be in these commands, it differs quite a lot between them. So it's not always the same. It's also RAM dependent. By that I mean that you have to load the entire data set into the working memory of the computer, the random access memory. And that can be quite a limitation if you're going to analyze large data sets, because then you would need a large memory in your computer as well, while, for example, SAS can keep the data set on a hard drive and then access it continuously there. But R can't do that. When you make an error in R, it can be rather easy to miss it, because as a default you don't see the data that you're analyzing, you just address it by writing the names of the columns and so forth. So instead of having a spreadsheet design where you can see that something is odd, you have only 0 values in an entire column or something like that. You don't see that in R, but you can see it if you ask for it, and you should probably do it, but otherwise you might miss errors you have made. And the pre-analysis part of the data handling is rather complicated in R, I would say, as compared to the analysis itself. If you're going to perform a statistical analysis, it's usually just a single command. It's very simple. But to define the groups, make selections, to code the variables correctly and so forth, that's not always very intuitive, and we'll keep a lot of focus on these things in the course. And finally, it can be difficult to find the right method, and that's mainly because there are so many packages around, and if you're going to perform some analysis, there might be a lot of good alternatives and possibly bad alternatives as well. So you will have to identify these and choose the one that is best suited for your needs. For example, I've performed a few meta-analyses, and there are a lot of meta-analysis packages in R, and you shouldn't use all of them, but you should choose one, and choosing this one can be a bit difficult.